So now we are going to analyze the inverting amplifier. Okay, and the way we will do it will be very much similar to the non-inverting one. So if you understand the previous one thoroughly, and if you do this next one, which is inverting amplifier, on your own, that will be highly pleasing. I'll be very happy if you do that on your own without watching this video, but I'll also do it in this video. Okay, so this is the circuit for the inverting amplifier. It has one input V1, one output VO. Vp is connected to ground. I just have copied it from here. Okay, we have said how to remember these circuits before. Fine, but now once again here, the question that we will ask is, given V1, if V1 is given, VO output is how much? How to find VO? Okay. How to find it? We need the static characteristic. So that is the input output relationship. So where is that? Let me draw it. This is the static characteristic, output versus input. Input is what? Vp minus Vn. This is how we draw it. And then this is the static characteristic, where this point is V supply. V supply is the power supply, and the minus power supply, this is minus V sub. Okay, and so this is the static characteristic. Now to find VO, we need both Vp and Vn. Now Vp is known, Vp is 0. Okay, so as before, to find VO, we need Vp and Vn. Now Vp is equal to 0 because this is connected to ground, but Vn is how much? Do we know Vn? Not directly, but we know something about Vn. So it's once again a potential divider rule, kind of potential divider rule. This point is at VO, this point is at V1. No current is getting out from this branch. Therefore, Vn will be somewhere in between V1 and VO. Okay, somewhere in between V1 and VO, some sort of average. Okay, and we can do it quickly if you know something like Millman's theorem. If you do not know, we can still do it. So let's find this current I, which is flowing like this. Okay, so from here to here. So this, if this current is I, how much is I? I is nothing but VO. This is at VO, this is V1 minus V1 divided by R1 plus R2. So this is I, and then we can write Vn. Vn is here, so this will be V1 plus this drop, V1 plus the drop is R1I. So this we can write V1 plus R1 multiplied by this factor, VO minus V1 by R1 plus R2, and then this we can write as R1 plus R2 times V1 minus V1, okay, plus R1 VO whole divided by R1 plus R2. This becomes, there is R1 V1. So this and this will cancel. So we have R2 V1 plus R1 VO divided by R1 plus R2, here divided by R1 plus R2. This is equal to Vn. So this is one relationship we have between Vn and Vo, because V1 is known. You can also write this as by multiplying everything with R1 R2. So let's write it this way: R1 plus R2 multiplied by Vn, okay, and minus R2 V1. This will be equal to R1 Vo, or you can jump a step and divide this by R1 by R1. So this is the relationship between Vo and Vn. Please verify my calculation. If I have made any mistake, please tell me. Okay, so this is one relationship between Vo and Vn. Okay, so we have two unknowns, Vn and Vo. Okay, to find Vo, we need, as we have already said, to find Vo we need Vp and Vn. And here also you see, to find Vn, it depends on Vo. So it's once again a chicken and egg problem. And so we have two relationships. We will have two relationships. Now this you call relation 1 between Vo and Vn, and another relation is here, the static characteristic. Okay, so this is relation 2. Okay, so we will also have two relations. So we can solve for Vn and Vo. Okay, now once again, so I have just copied these diagrams from the previous page so that we can continue. Now, and this is the relationship between Vo and Vn, which is coming from this. So this is coming from the external circuit. Okay, so this relationship, let me write here, this is coming from external circuit, and this is from op-amp's property, op-amp. Okay, so now once again we will draw two curves expressing this relationship and this together, but now we know that Vp is equal to 0, and this Vp is equal to 0. Therefore this is same as minus Vn. So in this curve, x-axis is same as minus Vn, since Vp is equal to 0. Now if I want to make this minus Vn to plus Vn, what I have to do is simply swap this or make a mirror image of this diagram like this. So this is a mirror image. Okay, so this is Vn versus output, because Vp is 0. And the second relationship, the other relationship between Vo and Vn is like this. So you see, Vo is Vn times something minus V minus something. V1 is known, so this is known. This V1 is given. Okay, so this is like Y is mx minus C. Y is mx minus C. So how can we draw that? Y is mx minus C. This will be a straight line with positive slope, and with intercept, so at Vn equal to 0, Vo will be negative, so it will start from a negative intercept. So this will be somewhat like this. So this is relation 1. So this is relation 1, this is relation 2, and what is the solution? The solution is at the intersection, which is here. Okay, so the solution is just this. So now for an ideal op amp, this line is almost vertical, right? So this almost goes like along the y axis. So for an ideal op amp, you can say that at solution, at this point, at solution, the value of Vn will be almost 0. Vn is almost 0, very close to 0. Okay, and then what is Vo? Then Vo, okay, if Vn is 0, then in this equation let's put Vn equal to 0, then we will have this is equal to minus R2 by R1 times V1, because this is 0, Vn, this term is 0 because Vn is 0. Okay, so this is the solution, so this is the answer. Okay, so the question was what will be the output? This is the answer, and you see the output is input times a negative factor. That's why we call it an inverting amplifier, because it the output is always of opposite sign from the input. Okay, okay, so yes, okay, and then okay, what's next? So next let us see how the output will change if we change the input. Okay, so if we change the input, what is input? This is input. Input is V1. So if we change input, this term will change, this will remain same. So in that means this relationship which is depicted here, this will change its position. How will it change? This will change, this factor will change, so the y-intercept will change, slope will remain same. Okay, so therefore if I change V1, then this curve is going to move like this. Okay, so then this curve is going to move like this, up or down, y-intercept is going to change. Therefore, but you observe that Vn, so at the solution Vn is going to remain almost 0. Okay, because this line is almost vertical. Okay, so Vn is going to remain 0 and this will also be true. So this is how the solution varies as you vary the input. Now say if you make V1 too much high, if V1 is too much high, then this will be too much negative, so this will go down like this, and then you see the solution won't be here, the solution will be here at the saturation region, it won't be here, it will be here, and then Vn will not be equal to 0, Vn will be minus Vn will be this and output will be minus V sub. Similarly, if you make V1 too much negative, then this term will be too much positive, so then this will go up, 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 up. Okay, up to this Vn will be 0, but beyond that the solution will be here, will no longer be on this axis, will be here. Okay, so this is how it moves. Let me keep it here. This is for some value of V1, positive V1. Okay, so this is how input and output changes. Now, okay, once again observe. Vn is almost equal to 0, which is same as Vp. Vp is 0. So Vn and Vp are almost same. Okay, this is once again is virtual sorting. So that means virtual sorting is also true for this circuit, which is inverting amplifier. But once again, let me tell you, this is not true for only the op amp. If we do not have all these connections, Vp and Vn will not be same. It will not be same for all circuits. It will not be same for only op amp. Once again, this is a property of this circuit, not of the op amp. This is a property of this circuit, okay, but not in general. Okay, so that's virtual sorting. Okay, so next we will try to do the same analysis for difference amplifier. But I will request you that if you have understood how to do it for inverting and non-inverting amplifiers, as we have done in the last two talks, last two classes, then you should try it on your own for the difference amplifier, and if you can do it, it will be really a fun. Thank you.